On today's episode, critical Starship details are revealed, Boeing Starliner hits another roadblock, and Dreamchaser prepares for launch. Not only has SpaceX set a date for the fourth test flight of their Starship rocket, they've also finally revealed the root cause of problems on Flight 3 that led to the premature destruction of their booster and ship stage. Save the date for June 5th. That's the target launch window set by SpaceX in a May 24th update, and Elon Musk has set the goal for Starship to survive the heat of re-entry into Earth's atmosphere. This is where we lost contact with the upper stage last time around, as it was rolling its way through a screaming hot cloud of plasma. In addition to the launch window, SpaceX has provided some clarity on Flight 3. The premature loss of the Super Heavy booster came down to a clogged fuel filter, which you might remember was also the cause of death for the booster on flight number 2. SpaceX says that 13 of Super Heavy's Raptor engines successfully refired for the boostback burn, but then 6 of those engines died out before completion of the burn, which SpaceX calls a benign early shutdown, meaning that it didn't have any significant effect on the flight plan. What did have a significant effect was that those 6 engines were now disabled for the landing burn, leaving 7 possible engines, of those only 2 successfully reignited. SpaceX lost contact with the booster 462 meters over the Gulf of Mexico. The most likely root cause was determined to be continued filter blockage, where liquid oxygen is supplied to the engines, leading to a loss of inlet pressure in engine oxygen turbopumps. Same issue as Flight 2, but with a much more successful result. SpaceX says they implemented hardware changes ahead of Flight 3 to mitigate this issue, which resulted in the booster progressing to its first ever landing burn attempt. They also say that Super Heavy boosters for Flight 4 and beyond will get additional hardware inside oxygen tanks to further improve propellant filtration capabilities. And utilizing data gathered from Super Heavy's first ever landing burn attempt, additional hardware and software changes are being implemented to increase startup reliability of the Raptor engines in landing conditions. As for the ship's stage, SpaceX chalks that up to more plumbing issues. They acknowledge that the ship lost attitude control during its coast phase, which prevented the engine relight test from going forward, and the lack of steering resulted in an off-nominal entry, with the ship seeing much larger than anticipated heating on both protected and unprotected areas. SpaceX says the most likely root cause of the unplanned roll was determined to be clogging of the valves responsible for roll control thrusters. SpaceX has since added additional roll control thrusters on upcoming Starships to improve attitude control redundancy and upgraded hardware for improved resilience to blockage. By upcoming Starships, it's not clear if they mean the ship intended for Flight Test 4 has the additional thrusters installed, but it doesn't sound like that's the case, so we may still get a repeat of last time, which was still a lot of fun to watch, so that's not a complaint. The space race is now coming directly to your inbox. We are launching the official Space Race newsletter, where you can get all the most important space news delivered to you in an easy-to-read format each week. Click the link in the description or go to www.thespacerace.news to sign up today. The first astronaut mission aboard Boeing Starliner has been tentatively set for June 1st, even as repair crews continue to chase new problems with the long-suffering space capsule, and leaving us on the edge of our seats with anticipation. Set to be a landmark event in commercial spaceflight, the mission has encountered several technical issues that have caused repeated delays. Most recently scheduled for launch on May 25th, NASA officials announced the latest delay on May 21st. The problem? A small helium leak in one of Starliner's thrusters that the team has been examining over the past few weeks. Or at least that's what they believed the problem to be, until they started finding new problems in the process of repairing the first problem. In a briefing on May 24th, NASA and Boeing engineers revealed that they are now looking at a combined mixture of technical failures on Starliner. Steve Stitch, manager of NASA's Commercial Crew Program, told reporters, "As we studied the helium leak, we also looked across the rest of the propulsion system just to make sure we didn't have any other things that we should be concerned about. As you may have guessed, there were indeed other things to be concerned about." Steve went on to explain, "We found a design vulnerability in the propulsion system as we analyzed this particular helium leak, where for certain failure cases that are very remote, we didn't have the capability to execute the deorbit burn with redundancy." Just to quickly simplify that, This is not an issue with any of the primary systems. It's a potential failure in a backup system that would only come up in a very unlikely circumstance, and this is the kind of stuff that was more or less expected to happen. The crew flight test mission to the International Space Station is developmental, meaning it is designed to test and refine systems and procedures before regular operational missions commence. For this reason, NASA and Boeing officials have repeatedly emphasized safety over schedules. NASA CFT astronauts Butch Wilmore and Sonny Williams, both former US Navy test pilots, have echoed this sentiment. Starliner appeared ready to fly on May 6th, but the countdown was halted just 2 hours before liftoff due to an oxygen relief valve issue on the Atlas V rocket, which is set to launch the Duo from Cape Canaveral Space Force Station. This issue was discovered while the helium leak was also being monitored, but engineers did not deem the leak a launch concern at that time. United Launch Alliance decided to address the buzzing valve issue without astronauts on board. After a few hours of evaluation, the team elected to pull the stacked rocket back to shelter to replace the valve. While at the ULA facility, the team looked into the helium leak and announced delays, first to May 21st and then to May 25th. NASA officials explained in an earlier update, the extra time lets the team take a closer look at a small helium leak in the Boeing Starliner spacecraft service module, which was traced to a flange on one of the reaction control system thrusters. Helium is a non-combustible gas and does not pose a risk during ground operations, but proper pressure is needed to send propellant to Starliner's engines. This helium leak was found in a part of the spacecraft used for small maneuvers in orbit. Starliner is only authorized to dock to one port of the Harmony module of the ISS on this test mission, so NASA needs to keep that spot open for the crew flight test to launch. If the fix takes several weeks, it may be difficult to hold the spot open given the ISS hosts other cargo and astronaut missions, adding to the uncertainty of the launch date. Williams and Wilmore had remained in quarantine through the launch delays, flying back to NASA's Johnson Space Center in Houston in mid-May. NASA did not say if the astronauts will emerge from their quarters, but if the delay persists for many weeks, they will likely leave to focus on other crew flight test training duties. Developmental delays often arise in new space programs. Boeing and SpaceX were both tasked by NASA in 2014 to send astronauts to the ISS using commercial crew vehicles, with the target date for astronaut flights set for 2017. SpaceX successfully flew its first Crew Dragon with astronauts in 2020, but Starliner has faced more challenges. Starliner failed to reach the ISS during its first uncrewed test flight in 2019 due to a software glitch that stranded the spacecraft in the wrong orbit. A follow-up flight made it to the ISS safely in 2022 after addressing dozens of issues, in addition to delays due to the coronavirus pandemic in 2020. The crew flight test was delayed further in 2023 after the team found the capsule's parachutes could carry less load than expected and discovered flammable tape covering much of the wiring in the spacecraft. These issues have all since been resolved according to NASA and Boeing officials. We all await more updates on the launch date for this important mission and hope the issues will be resolved soon, as this is a crucial component of the future human spaceflight missions. The Dreamchaser spaceplane Tenacity has arrived at NASA's Kennedy Space Center in Florida and is getting ready for its first cargo mission to the International Space Station. Built by Colorado-based Sierra Space, this innovative spaceplane is designed to transport cargo and astronauts to low Earth orbit. Drawing inspiration from NASA's space shuttle and Soviet-era designs, this reusable vehicle represents a new era in space travel. On May 18, 2024, Tenacity arrived at Kennedy Space Center for final testing and processing. This crucial phase includes acoustic and electromagnetic interference testing, thermal protection system work, and payload integration. After these steps, Tenacity will be ready for its maiden voyage to the ISS. Tenacity's first flight, scheduled for late 2024, will launch atop United Launch Alliance's new Vulcan Centaur rocket from Cape Canaveral Space Force Station. Along with its cargo module, the Shooting Star, Tenacity will deliver an impressive 7,800 pounds or 3,500 kilograms of supplies to the ISS. Unlike traditional capsules, Tenacity is designed to land on conventional runways, enhancing safety and reducing costs. This innovative design combines the efficiency of airplanes with the capability to reach space, opening new frontiers for space exploration. Dreamchaser's applications are very diverse, from cargo resupply missions to the ISS to potential crewed flights. It promises a new level of versatility. This mission marks the start of Tenacity's journey with future roles in military operations, in-orbit servicing, and supporting private space stations like Blue Origin's Orbital Reef. But Tenacity is just the beginning. Sierra Space is already gearing up for their next breakthrough. Sierra Space has also started production on a second spaceplane named Reverence. This addition will expand the fleet and increase launch frequency. Lessons learned from building Tenacity have reduced issues on the second vehicle by 80%, resulting in quicker assembly and lower costs. Developing spaceplanes like Dreamchaser marks a significant milestone in the history of space exploration. Drawing from the legacy of the space shuttle and advancements in aerospace technology, Dreamchaser embodies decades of innovation and ambition. Its ability to land on runways worldwide signifies a leap forward in making space travel more accessible and sustainable to all. The collaboration between Sierra Space and NASA under the Commercial Resupply Services 2 contract highlights the importance of public-private partnerships in advancing space exploration. These partnerships bring innovation, efficiency, and shared risks, paving the way for more ambitious missions. Sierra Space is working closely with NASA to plan the manifest for cargo flights to the ISS, with Dreamchaser joining Northrop Grumman's Cygnus and SpaceX's Cargo Dragon. As Tenacity prepares for its first flight, excitement builds. The Dreamchaser is poised to change how we explore and utilize space, bringing the final frontier a little closer to home.